Let's finish off the problem we started last time then from chapter 6. And fortunately, it's left here. I was afraid I'd have to rewrite it or ask you where we were and hope that someone had written down the numbers we had. Well, actually, we had found the reactions, EY and E and AY, and we had noted that we probably will not be able to separate AX and EX, but that's okay. As a matter of fact, at the end of class, what we had done is drawn point A, right, this joint at A, and realized that that joint could yield the magnitude of FAB. Because FABY must be 425 pounds. As a matter of fact, do I have FAB drawn in the correct direction or is it the wrong direction? It's the wrong direction, isn't it? Because we know AY acts upward, and to keep this point in vertical equilibrium, according to this, FABY must be negative. So I've got it in the wrong direction, don't I? But that's okay. So to calculate the magnitude of FAB, what I'm going to do is write down the components, and I got stuck here because I thought, oh great, now I got to deal with geometry again. Fortunately, a kind student noted after the class to me that these are all 3, 4, 5 triangles. So this, if you look at the ratio of these sides, this is a 3, 4, 5 triangle, even though it's 3.755, 6.25. Let's verify that real quick, if you would. Is 3.75 over 5, is that equal to 3 over 4? Is that 3/4? Mm-hmm. So, okay, so they are all 3, 4, 5 triangles. That makes our life a little easier. So what that means is basically the horizontal and vertical components of this are easy to write down. For example, we'd have 3/5 of FAB. Everybody follow that? To get the Y component. Okay? So we can calculate FAB. Okay? And I guess I shouldn't have put a negative sign here because I need to remember that it's in the wrong direction. So it would have to be negative 425 pounds force times times 5/3, not 3/5. Got to invert and multiply the fraction, right? All right, grab your calculators, please, and let's find out the magnitude of FAB. This will be the force in our first moment, or in our first number.
We got negative 708.3 repeating.
I'm going to write 708.3 repeating, and I'm going to put an indication that, think about it, if the force on this point from the member is in this direction, which it's not, right, it's in the opposite, but if it were in this direction, then FAB would be in tension. Does that make sense? Mm-hmm. So therefore, it's not, it must be in compression. Let me move B here, and I'm going to put parentheses C here. That doesn't mean copyright. What that means is compression. So I'm just making a note. In fact, what I might do, because I'm running out of space, is put a C above the number. Okay? Well, that was nice. What should we do next? Any ideas? Well, we get another result out of this point, because think about it. AX, we said, and EX have to sum up to a certain amount, right? But we don't know how much, so we should be able to calculate the magnitude of the force in this member. So what we could do is sum forces in the horizontal direction and find the magnitude of FAG in relationship to AX. However, I think what we might do is move on to this point. As a matter of fact, there's something that's happened here. Remember we talked about zero force members? Does anybody see one?
Wouldn't BG be a zero force member?
Yeah, there's 2 linear pieces.
Yeah, so these two are along the same line, right? And so if we had any force from B at this point, there would be nothing that could keep this point from accelerating. And so we know immediately that BG is a zero force member. Maybe I'll indicate it that way, I don't know. Is DF a zero force member? Because it looks symmetrical.
No,
Be careful.
you got
We've got a force here, don't we? But could you tell me the magnitude of the load in DF? I know we're jumping around a little bit. Think about it. think about a free body diagram of point D. Somebody said it has to be equal. You're right. Equal to what?
Equal to P2.
Equal to P2. Why? Because that's the only thing that can resist it. The other two members can't have any force in the direction of P2. Only DF can have. And so is DF in compression or tension? Compression. And its magnitude is 400 pounds. Right? Now that we've got that, could we go to point F? I think this is going to be the key for answering the question about AX and EX. If we go and move on to point F, we need a free body diagram. We know member DF is in compression, magnitude 400 pounds. FE we don't know anything about. We'll assume that it is in tension. Let's see, that's probably not the way I should write it. How about FX, something like that. And of course this is point F, like that was point A, because we've got forces to indicate. And then I will assume a positive direction for, well, I guess I have to call this FFC, something like that. The force in link FC is what I mean. And maybe we just call it FC. Just whatever you want to call it, it doesn't matter really. Could I solve this one? Well, let's find out. Sum of forces in the y direction, sum of forces in the x direction. Well, summing forces in the horizontal direction, there's a contribution from Fx and Fc. So how about if we sum forces in the y direction to begin? So since all of this should be set up as, I think this is all set up as 3, 4, 5 triangles like he said. So is this also a 3, 4, 5? I think it would have to be, wouldn't it? Because let me show you the triangle I'm thinking about. So we've got point E over here, point D here, and point F here. The reason I'm thinking about this triangle is because I'm trying to figure out the sense of 400 pounds. In other words, what direction it's oriented. And so we do know that this is a 3, 4, 5. And so if I drop a line from D so that I have another perpendicular triangle, yeah, this one would have to be similar to that one because we've got lines related to the other lines. So yes, this is also a 3, 4, 5 triangle, but now it would look like this. This would be the hypotenuse. It would be like that. Does that make sense to everybody? Any questions? Okay. So to calculate the magnitude of the 400-pound load, well, it's negative, first of all. 400 pounds multiplied by, let's see, I'm looking for the vertical component, so 4/5. Okay? And then plus FC's y component. Now for FC, I've got to think about that triangle as well. Let's see. Looks more like this. And we know it's also a 3, 4, 5. And so, let's see, I think that what I'm interested in is this triangle, and I'm not convinced that it's a 3, 4, 5. I think it will end up being, because I think it'll end up being symmetrical, or I think it'll be a mirror about this point, but I'm not positive. Let's double check that. How do we prove that? Well, we know the angle down here, don't we? And we know the angle up here. We can get either one of those angles that we like. Let's call this one alpha, and let's call this one beta. And so if what I'm interested in is a line parallel to that one, I haven't drawn it very well, but it is parallel, and I'm interested in this triangle. Let's see, so this line and this line are parallel. I may have talked myself into a corner here because I'm not sure that I've got a good proof. Let's see. Draw that again. You know what I would do at this point? I would just draw it in SOLIDWORKS because I'm drawing a blank on the geometry. So let's just try that really quick. Oh, by the way, I want to point out something. I've added a couple of, well, you can't see it, can you? I've added a couple of videos. You guys know that I watch too much YouTube, but I often come across videos that I think are very closely related to the topic of the courses I teach. So if you get the chance, you should watch some of these videos. I think you'll like them. If the screen will come on. There we go. So there's one by Grady, which is, I think, Practical Engineering. It's his channel. And of course, there's Mechanical Advantages as well. Both of these are talking about moments, which are related to Chapter 5. So if you get the chance, watch them. They're not very long. In fact, the Grady video, if you ever watch any of his, he makes very high quality stuff. This particular one is about 5 minutes. The Efficient Engineer Mechanical Advantage video is about 10 minutes, I think. Well worth your time. Anyway, let's make a new part quickly. Let SOLIDWORKS solve the geometry. Probably a clever way to prove that. I can't think of what it is right now. This is not a geometry class.
Do you need to move the camera to show it?
I will in just a moment. In fact, I guess let's go ahead. You may as well see me draw.
They need TV as well.
Make the TV a little more normal to the, or parallel to the camera. All right, so let's lay down what we know, which is something like that. We know that these two lines are equal to one another. And what else did we know? Oh, they gave us some geometry, didn't they? So let's just use the geometry they gave us. Didn't they give us distances, horizontal distances, I think? Something like that. No. What was it? 4 feet, that's what it was. Okay, and then this is a length of 4 foot as well. And, nope, that's not what I want. I want, okay, so why didn't that work? Am I wrong to think those two dimensions are the same? Pardon? Oh, I know what's wrong. It's because it's the center point here that's 4 feet. So if we put a center point mark on this so we can dimension to it. And guys, you're welcome to talk in my classes. The only thing I ask is that you whisper, okay? That's still not a whisper. Okay, what is it upset about?
You don't have the height.
We do need a 6 foot height, that's true. All right, so now it's completely defined, and these two should have the same length. Let's find out. 86.53 and 86.53. Okay. So what I've done so far is just drawn CFE. Do you see that? CFE. But the triangle I'm really interested in there is really CFD, which is right here, CFD, and how it relates to, well, this direction right here. So I'm going to lay down, no, we already took care of that. It's this one over here I care about. Oh, I see what I missed. Okay, so what I should have done is just said, you know what? We know the height and then we know the width, and that's the same as this width and this height, right?
No.
And then that would have been it. So again, certainly it is a 6, 4, 5 triangle because, well, no, wait a second. What did I do wrong? I've got a 4 foot, oh, I've got, yeah. Yeah, this is wrong. I think the geometry still works, but you're right, I should have had a 4 foot dimension to here. There we go. So I think the geometry, well, no it doesn't, because now I don't know that horizontal distance anymore. Okay, so now SolidWorks can give me the components of this, that's easy enough. Evaluate, measure this, and okay, it gives me the length, but what about, why is it not giving me, oh, I know why. I'll show you different. Instead of clicking on a line, if you click on 2 points, then it'll tell you the distances between those in both X and Y directions. I'm sorry I can't make this any larger, but what it says is in the X direction, we've got a 21-inch length, and in the Y direction, we've got a 72-inch length. Of course, the 72 inches you already know. And of course, we can convert it since that's inconvenient. We'll just use custom settings, and we want feet instead of inches. There we go. So 1 3/4 foot this way, 6 foot this way. Okay? All right, so now that we've got that information, let's go back to the board and get it all in view. I think that's all in view. And now I don't have to mess with the geometry, I can just use it. So I'm glad I did that because I was thinking it was just a mirror image triangle that is another 3, 4, 5, but now I don't think that's the case. So let's see. What I was trying to do was get components of FC. So we're going to have a positive vertical component. Let's write FC, and we want the Y component, but now that I've got my triangle made, I should be able to figure out the Y component because it's going to be 72 inches, or in other words, 6 feet divided by the length. So that's 6 over 6.25. Everybody see how I did that? Any questions on it? Okay. So that's the sum of the forces in the Y direction equals 0. So now we can calculate FC. FC then would be equal to 400 times 4/5 multiplied by 6.25 over 6. Just rearranging everything. Okay? So grab your calculators, please. Let's find out what this number is. And we'll have the force in FC. I don't know, is that what everyone got?
That's what I got, yeah.
Okay, so we're right, 333.3 repeating, and this is member CF. And what did we decide? I had drawn this as positive, and it must be, right? So this must be tension. So for member FC to pull on this point must be pulling back on FC, member FC, causing a tensile load. Does that make sense to everybody? Okay. Now we can sum forces in the X direction. We've got F in the X direction, and there was the force from point E, for example, in the horizontal direction. And then we're going to have minus 400, because notice there's a negative component of the 400-pound load. In fact, it should be 3/5. And then we've got a negative component from FC, so minus FC. And now we need the horizontal distance of FC, which is what? 1.75 feet. So 1.75 over the magnitude of the hypotenuse, 6.25. And so calculating Fx is pretty straightforward. All we have to do is take 400 times 3/5 and FC times 1.75 over 6.25. So if you have that 333.3 repeating, just multiply it by 1.75 over 6.25, and then add to that 1,200 over 5. Because 3 times 400 would be 1,200. So what's the magnitude of the force in the X direction? I guess I could write it here.
I got that it's also 333.3 repeating.
Okay.
That's what I got as well.
Sounds good. So notice that it's also a tensile load, right? So this is in tension as well. And then where should we go from here? What do you suggest? if we go to point E, we have the unknown EX, right?
Mhm.
And we have this, DE component. But notice we know one of the forces. So I think this will prove to us whether EX is taking all of that 240-pound load or not. Which, by the way, I think it is, but I'm not sure. Let's find out. So let's write down a free body diagram. For point E. And we'll write that we've got DE. We've got a tensile load like this of FE, which we've just computed. And we've got, what have we got? EY and EX. Okay? So we know, actually this may not help us. No, we know two of these. We know EY, don't we? We know FE and EY. Yeah, we can do this. So notice that EY is going to give us the magnitude of DE by summing forces in the vertical direction. So to do that, I guess the way to do it is EY minus, well, plus DEY equals 0. And then we can figure out DE in terms of EY. All I need is the percentage of it, right, that acts in the Y direction. Probably get that from the geometry over here easier because it's this line that we're interested in. I think it's going to end up being 3/5 or 4/3 or 4/5, one of the two, depending on which. We'll just add some geometry to this and make our lives easy. Let's see, edit that sketch. Oh, I guess we're already in sketch mode. Yeah. Okay, so the triangle I'm interested in is that one. I guess I should show the camera what I'm doing too. So I've just added a triangle over here. And now I can, well, I guess I could have simply measured point to point, couldn't I? That would have done it as well. So evaluate, measure from here to here. It's a distance of 5 feet. Yep, it's a 345. You see that? We've got a 4 foot horizontal distance, 5 foot hypotenuse, and 3 foot height. Okay. So that's another 345. So if we go back over here to try and get DE in the Y direction, then I think we need what, 3/5? Right? So DE would be equal to negative 5/3 of EY. So when we do that, we need 495 times 5/3. What do we get for that? 825. Okay, so DE is 825 pounds, and that must be in compression, right?
Yeah.
Because we assumed tension, which is what you assume by default, but in reality it's compression. Okay? Now, if we sum forces in the x direction, we should be able to find EX, and then we'll be able to find AX, and then we can go around whatever we want. Okay, so summing forces in the horizontal direction, we'll get DEX, let's see, in the negative direction. Really, it's going to end up being positive because DE itself is a negative thing. We've got to remember to plug it in that way. Plus EX minus FE, and I think that's, yeah, that equals 0. That's everything in the horizontal direction. So EX will be equal to FE plus DE in the x direction. FE is 333.3 repeating. And DE is itself a negative thing, but I'm going to go ahead and write plus DE. To get the x component, that would be the 4/5 side, right? And so when we plug in DE, we're going to plug in negative 825. Okay? So take 825 times 4/5 and add to it 333.3 repeating.
993.3 repeating.
We should, did you plug in a negative 825?
No, I did positive.
Yeah, plug in negative 825.
We got 326.67.
I'm wondering if I've made a mistake so far, because I expected this number to come out to 240 pounds. I may be wrong in that. What I'm gonna do is between now and next class, well, next class is the test, isn't it? But between now and a week from today, I'll work out this problem. Make sure I haven't made a wrong turn somewhere, because I'm not 100% confident on the geometry. I know the overall method we're using is correct, but I'm not confident on the geometry. So rather than messing with trying to figure that out and possibly making a mistake, I'm just gonna go into SolidWorks and draw it all and go from that, okay? Make my life easy. Was there a question over here?
So the numbers for your forces are correct so far.
Are they all okay? How do you know?
I'm checking the back of the book just to make sure.
Oh, okay, well, we're on the right track, good to know. So I'll finish off this problem by writing it out, and that way we'll be a little more efficient in finishing the problem overall, okay?